Welcome back. Let us continue our discussion for the subject Big Data Analytics, meant for semester 7 CSE Computer Science students. We have finished discussing Unit 1 and we'll be discussing Unit 2. Unit 2 syllabus is Apache Hadoop Distributed File System, denoted as HDFS, Architecture of HDFS, Applications, Operations, Read-Write File Operations, Parallel Copying by Disk Cop, Hadoop I/O, Data Integrity, Compression, Tools and Algorithms, Serialization, Hadoop Configuration, Apache posing. So let us focus today's discussion on HDFS, architecture of HDFS and related terminologies. If you remember the previous discussion, we had seen the core components of Hadoop being map, reduce and HDFS. And we know that map, reduce is for processing and HDFS takes care of storing. And this was supported by yarn and common utilities. And this is what Hadoop components were depicted as. You have your machines divided into name node and many data nodes. So the name node is designated as master while the data node is designated as a slave. And you also have a resource manager called as a master. And just to confirm, all these contents we have derived from Edureka site, which felt simpler, and even Hadoop architecture and related technologies discussion was also derived from a link of Edureka YouTube video. The same I am sharing here with you. So if you look here, the resource manager and the name node can be on the same machine, and you can have multiple data nodes. But it also may happen that in the actual scenario, the resource manager may be on a separate server and the name node may be on the separate server. Okay. So this was how your machines are divided into name node and data nodes. As you can see here, the name node stores the metadata. The name node monitors the health status of the data nodes, and the name node assigns tasks to the data nodes. Similarly, the data nodes, what actually they will be doing, they are the actual unit which will be storing the data. So it will be responding to the name node with a heartbeat indicating its health status. You also have a secondary name node. So it's a buffer to the name node. What it does is it stores the intermediate updates. There is a FS image of the name node in the edit log and update the same in the final FS image when the name node is not active. This was what we had spoken about previously. Let us continue our discussion for the topic HDFS, which stands for Hadoop Distributed File System, the architecture of HDFS. This is what we were speaking about. You have machines called as name node and you have many machines called as data nodes. The name node is called as a master node or a master daemon, and you have data node designated as slave daemon. Okay. So what the name node does is it will be managing the data nodes. It will be maintaining the metadata like location of the block stored, the size of the files, the permission, the hierarchy. It receives heartbeats from the data node and it can also block report from all the data nodes. So when we are speaking about HDFS, the long form is Hadoop Distributed File System. When I say distributed file system, the file system storage is across a network of machines. And what is HDFS then? It is specifically distributed file system for Hadoop. It will be storing huge files, and streaming data access pattern is there. It will be running on cluster of commodity hardware. What is the meaning of streaming? You have constant bit rate during data transfer. What HDFS does is, it has the concept of a block, say a block of 128 MB by default. So why it uses the concept of blocks? To minimize the cost of SIGs. And in HDFS there is something called as replication, and by default the replication factor is 3. The simple meaning of that is, suppose a block is copied, actually this single block is not copied, its 2 copies will be copied. So suppose 1 terabyte of data you are copying in HDFS, actually you are copying 3 terabytes of data, which means that it's a replication, duplicate of that. If you look at this diagram, what it is indicating, this is at the top is a master machine, which is called as a Hadoop cluster, and here your name node may be residing, as well as here the resource manager may be residing. Now this name node will be interacting with data nodes. This computer 1, computer 2, computer 3, all these are called as the data nodes. Okay, so they'll be interacting to these data nodes through the switches. So you have core switches, and as there are hundreds of machines, those hundreds of machines are called as data nodes, which are running on commodity hardware, and they'll be sitting in different racks. So basically this is what is the arrangement in a Hadoop ecosystem. So the slave machines, many slave machines are distributed over the cluster, and they are sitting in different racks. Let us look at the concept of block here. Now you can, there are 4 nodes visible here: node 1, node 2, node 3 and node 4. So these 4 nodes, we call them as data nodes, we call them as slave nodes or slave daemons or slave machines. And you can also see here color coded blocks. So block 1, block 2, block 3, block 4, block 5. Let us look at block 1. So block 1 is stored in node 1. Similarly, its replica is stored in node 2. Similarly, its replica is stored in node 4. It means what? Block 1, by default in Hadoop, as the replication factor is 3, you can see there are 3 copies of block 1. Similarly, you can have 3 copies of block 2, block 3, block 4 and block 5 also. Now, if you look at this diagram, what it is saying is your blocks may be stored on different data nodes, and these different data nodes may be residing in different racks, The Hadoop ecosystem uses something called as a rack awareness algorithm, to keep track of the blocks, to store the blocks, kind of. Say for example here block A, block B, block C, you're seeing them color coded. Block A is in node 1 of rack 1, as well as block A is in node 6 of rack 2. Similarly, block 1 is in on the same rack 2 of node 8. So this is how rack awareness algorithm helps in keeping track of the replication as well as the blocks. If you look at this diagram, it is speaking about the architecture of HDFS. What is the long form of HDFS? Hadoop Distributed File System. In HDFS architecture, what is visible? You have a name node. What is the meaning of a name node? Master node. What the name node and master node does? It will be keeping track of the data nodes. It will be monitoring the data nodes. It will be allocating the work to the data nodes. It will be listening to the data nodes status, health status through heartbeat sent by the data nodes. Now, where the data nodes are residing, at least in this diagram, you have 3 data nodes residing in rack 1 and you have 2 data nodes residing in rack 2. And you can see that here there is a replication factor, means one block, maybe if the default replication factor is 3, the same block is at 3 multiple places. Okay, so what is happening here? You can see here there is a name node which is maintaining the metadata. Okay, so there is a read operation being performed by the client, and the client is reading from the data nodes, as well as there is a write operation performed by the client which also is being performed from the data nodes. So reading and writing from the data nodes. Let us look at the write pipeline. Let us look at the write pipeline through this diagram, which I already told that we have extracted all this diagram from the Edureka site YouTube videos. So let us look at this. This is the client node. This is the client node. What the client node is doing? The client node is sending a write request. It wants to write block A. It wants to write block A. It is sending the request to whom? To the name node. To the name node. And what the name node is doing? The name node is sending the IP addresses of data node 1, data node 4 and data node 6. What it indicates? The name node is telling the client that you can write the block A in the data node 1, data node 4 and data node 6. What the client node will be doing? The client node will be going to core switch, and from core switch it will be going to the specific switch, and from there you can see here block A is being written at data node 1. But before that, what is happening? It is checking the readiness of data node 1. Okay, so are you ready to receive the data? Okay, once it gets the acknowledgement, then the data node 1 will be receiving block A. After that, the data node 1 will be creating a replica in data node 4, while the data node 4 will be creating a replica in data node 6. So data node 1 resides in rack 1, data node 4 and data node 6 reside in rack 5. You can see here what's happening here. The client has sent a request. What request? Write request. Okay, so to and this is to be written where? Data node 1, data node 4, data node 6. Okay, so data node 1 is written, block A is written at data node 1. Data node 1 will be writing the block A to data node 4. Data node 4 will be writing to data node 6 block A. This is the acknowledgement mechanism wherein the client at the end sends an acknowledgement to the name node saying that its operation is completed. Its operation is completed. Okay. So, but let us say that was the scenario when there is only one block. But here you can see block A and block B are there. In such a case, block A and block B will be parallelly written. To the data nodes, will be parallelly written to the data nodes. After that, there will be a sequential replication. Of the blocks to the particular data nodes. So similarly, this diagram will be depicting the read architecture in HDFS. Who is sending the read request? The client node is sending the read request. What it wants to read? Block A and block B. To whom it is sending the request? To the name node. What the name node will be doing? The name node is sending the address of the data nodes, that is data node 1 and data node 3. Now the client will be through the core switches reaching out to switch, and from the switch it will be reading the data node 1, and after that it will be reading the data node 3, and this is what is the read architecture is all about. So that was what we started discussing unit 2 of the subject big data analytics. That too specifically today we focused on HDFS, that is Hadoop distributed file system, That too, the basics of architecture of HDFS. Okay, so let us continue our learning of big data analytics and in the further videos.